Hello, everyone. Welcome to the episode 4 of the Delta Dialogues. It is your monthly shot of inspiration, information, and an opportunity to connect and align with a broad integrated photonics community. Our main goal with this series is ultimately to stimulate and to engage in a broader dialogue, to provide you with the updates on the latest developments in our ecosystem and beyond, as well as to introduce you to our partners and other innovative thinkers and the practitioners in our industry and the field. And before I tell you more about myself and about the exciting lineup of speakers and presenters we have today, I would like to give you a small reminder that this is essentially designed to be an interactive session. So please be active, ask your questions, reach out, and this is what we're here for today. Few things from the very beginning. I'd like to introduce and say a few more words about myself. So my name is Nilüfer Bulut. I'm a program manager for strategic partnerships at Photon Delta, in the lead for a few European projects. I work closely with broader clusters, big clusters, and some policymakers and SMEs in Europe and globally. And I'm very excited with this opportunity to be your host today. My colleague Jorn, who is your usual host, is safe and sound. I believe he's on his way to United States of America, and he will pick up the hosting role as per usual for all the upcoming episodes. And I will, in the meantime, use this privilege to interact with you. And today, we will begin with a brief introduction and an overview of what's to come in a day. So let me run you through the program really quickly. We shall kick off with a very special guest, Peter Doyle. He's a business coach and a leading person for all of the scouting activities within PhotonHub Europe project. I think he will tell us more about the project. He will elaborate on the innovation support activities that are available for the European SMEs. And following that, I also very much hope he will inspire you to engage and to apply with this project more closely. Then we'll move into the Who is Who section. We will start with Erik van Genoegte, who is a co-founder at Sensing 360, who will present the company and the technology to us. It will be followed by John Joosten, who we have a pleasure of having here in person. He's a marketing technologist from FuQon, and he will be followed by another special presenter, Hans Dijk, who is a business development manager at the Surfix Diagnostics. And we will conclude today's episode with another person in the spotlight section, where Tim Tiek, who is a board member at both Holland Semiconductors and Hightech NL, will share his vision on the worlds of electronics and photonics. So I'm very excited about this lineup. Let's begin. Peter Doyle. Hello, Peter. I hope you can hear and see me well.
Yes, Nilüfer. Good morning, good afternoon.
Yes, good afternoon here. It is excellent to have you on board with us today. And without any overdue, Peter, please say a few words about yourself. And please, by all means, start telling us about PhotonHub Europe project very briefly. And I will have a few more other questions for you in-house. Welcome. The floor is yours.
Thank you, Nilüfer. And it's a pleasure to be here and to, I guess, address everybody. Unfortunately, we're online, so but we're used to this now. But if you can see and hear me clearly. I don't have slides to present, so this is just a discussion, but I'll talk a little bit about PhotonHub and what we do and what how we can help companies and how we work as part of the photonics ecosystem across Europe. So firstly, my name is Peter Doyle. Yes, I'm part of the central coordination team out of the Vrije Universiteit Brussels in Brussels. We are the central coordinator of PhotonHub. Okay, but actually we're a massive consortium, over 50 partners. We just have the small job of coordinating everybody. So amongst those partners is Photon Delta. But what we represent basically is a single one-stop shop at a European level for photonics across Europe. So we're all familiar with the phrase of think global, act local, right? something that we've had to adjust to really since globalization, in seeing that the world is much bigger in one sense than our local environment, but also getting smaller. So competition can come from anywhere. Great products and innovation can come from anywhere. Supply chains can be anywhere. So what's essential, of course, is that on a European scale, the European project, that we take advantage of the fact that the best things for us might be available anywhere in Europe. And actually, we should be able to access those. So while a local solution is ideal, and of course, as you know, Nilüfer, a Dutch SME in photonics or looking for photonics help, they're probably maybe their first port of call should be Photon Delta, for example. But perhaps what they're looking for is not necessarily available in the Netherlands. Maybe it's available from Germany or Switzerland or France or Ireland. In terms of the photonics technology expertise they're looking for, that is the purpose of PhotonHub, is to connect those by working directly with the companies, the partners, to make these things happen.
Oh, that's perfect introduction. And actually, Peter, you stole my first question, because my first question would be, why is PhotonHub Europe important for European photonics industry? And essentially, if I summarize you correctly, your first part correctly, is we are treating the whole European photonics players as a one dynamic ecosystem, going much beyond the fragmented borders of specific players or clusters within the countries.
Exactly, Nilüfer. And it's not to underestimate the importance of the local clusters and the national initiatives. And of course, again, the Netherlands is the leader in Europe in the photonic integrated circuit area. But even still, our strength is stronger when we look to all the opportunities across Europe.
Absolutely,
so,
absolutely.
And to connect to those, if the solution is best, then it's fine. It's great to come back local, but it's to combine the best of both worlds, of course.
Absolutely. Well, now, Peter, we are unfortunately under a time limit, and I'm going to move on to the second question.
Okay.
So could you tell in a bit more detail to our audience about the support opportunities, services, innovation support opportunities, as we call them in the project, relevant for the SMEs, and to excite, to motivate, and to inspire them actually to pay attention and to get engaged more closely with PhotonHub?
Super. And there's a lot to obviously describe, Nilüfer, but I'll try and summarize it in simple terms. We are not just about connecting companies and just telling them where to go. Actually, we're about engaging very interactively with companies and doing co-innovation activities. So if there is, for example, an SME in the Netherlands who has an idea about a new medical device that somehow is using fiber optics or a lens, maybe a camera lens that they need for their device, they have a lot of expertise at the system level, and around the medical device, perhaps, and the electronics, maybe even, or the software. But certainly the photonics can be very specialist, and it's not something they can easily access. So for that company to have a one place that they can come to, maybe they come first to Photon Delta, and Photon Delta then connects them with PhotonHub. What we do is look based on their business need, not the technology push. What is the best technology to match their need? Which partners within PhotonHub have that expertise, and how can we do an innovation project together? So we can start from the early stages of a feasibility, so developing a first demonstrator, first prototype. And what's really nice about PhotonHub and the partners is then that we have also pilot lines, so we can then start to look to develop the first 100,000 units and scaling up the production of those prototypes right into mass manufacturing. So it's a one-stop shop, not just in terms of the diverse range of photonics technologies, the diverse range of partners across Europe, but also that value chain from the early TRL, technology readiness level of a concept, all the way through to a fully ready product. So one place to go. So we subsidize the projects, which is good news, especially for SMEs. There's a lot of risk in developing your first prototypes. So we help subsidize the cost of doing that. Of course, as they move up, they need to put some of their own cash on the table, but we're really de-risking it massively. And then in addition to that, what we would call test before invest type innovation support. And those are typically 6 to 9 month type projects, so very rapid, go-to-market projects. We can help them with training, because the idea is that they should bring the skills in-house as they go and become self-reliant, and also with support to find investment. So
Perfect.
Not every SME company needs to find an investor, but there are many who also need, of course, investors, and we have to match them with those as well.
I think in this brief minute or so, you mentioned a lot of important things. So you said we're going beyond the scope of one country and one cluster to source everything, the best we have in Europe, to implement your project. You're also saying that we can start very early on and hold your hand, so to speak, and graduate you towards higher TRL levels. And then also you said a few things that can happen in terms of funding support and guide and coach companies in this direction as well. I think this is excellent. And I'm sure if I ask you to elaborate on each and every aspect of those support activities, we can continue till the evening.
For sure.
But now maybe we can conclude with few words very briefly on what is the process. So I'm sitting on the other side. I'm super excited. I need these services. What do I need to do?
Yeah, and again, a lot of people in the audience may be familiar with European projects where you have to submit a very detailed proposal, and then you're one of thousands, and then you wait for an answer, and you have a low percentage chance. We have a very different procedure whereby, okay, it's online registration of an interest, so it's just an initial, very simple, this is who we are and what we're looking for support in terms of photonics innovation support. So you go to the PhotonHub website, photonhub.eu, and click the apply now or register now button, and that's a very simple web form that initiates but then it's a discussion between us and the company in terms of really understanding what their needs are. And then we have a phase called the scouting, where we'll put an NDA in place and we will actually have an interaction. We fund the expert on our side to discuss the details with the company. And only then, if everybody is happy that there's a good scope of a project together, will we proceed to a full detailed proposal. And it's an open call, Nilüfer, so it's continuous. It's not like there's one fixed deadline. Every 2 months, we're evaluating new proposals as they come in. And we're fully funded by the Commission for the next number of years. So it's very much when the timing is right for the companies. If it's not today, then maybe tomorrow, maybe next month, apply, start the process of engagement with us. Again, through the discussion, we might find their solution is local, or it's somewhere else, or it needs to be delayed by a few months or whatever. But this kind of interaction is really important to us. It's the dialogues.
Yeah. Starting the dialogue,
to steal your
putting the
word,
foot in the door.
dialogue.
Yeah, probably. Yeah. Okay.
Yeah.
Well, Peter, I couldn't have asked for more. It's really a pleasure and very beneficial for the audience. This will also be recorded, and a lot more companies and viewers will be seeing this. I'd like to thank you for your presentation. And I had few more questions and several other things I wanted to mention, but please bear in mind, I'm addressing the audience, that I'm more than willing and able to help you. If you have more questions, I can connect you to Peter Doyle. By all means, go on the website, learn more about the opportunities. And I thank you, Peter. And I very much hope it's not the last time we see you on this platform as well. Thank you very much for your input.
Thank you so much, Nilüfer. Thank you.
Okay. Well, now we move to our next section. Okay, now we're entering the new section in the episodes. It's called Who is Who? First in the line is Eric van Genoegte, who is a co-founder at the Sensing 360, and he will present the company and the technology. I welcome you, Eric. Great to have you today on board with us, and the floor is yours. Let's make the first initial check.
Thank you. Then I will share my screen because I do have some slides.
Yes, please do so. The floor is yours.
That should all work. So who is who? So my name is Eric. I have a background in quantum mechanics, and I started working in photonics about 16 years ago for my former company SKF, and that's what you see here. We're now Sensing 360, and what you see here is a bearing with light spots on it, and that's what we essentially do. We use photonics sensing, fiber Bragg gratings in this specific case, so light to sense bearings. And why do we do that? There's of course plenty of things to talk about. If you look at the photon delta ecosystem, we're really close to the application. So this one I stole, of course, from the site, but we are in the application, and we are also working together with quite some companies like Photon First to develop our solutions. So why do we sense rotating equipment? In general, we have the following issues, at least our customers have the following issues. That's you see here a ship or a crane or a motor or a wind turbine. They have a lot. There's the main challenges where we work on is discussions about design, and optimizing warranty or guarantee discussions. The second issue is that there's a lot of unplanned downtime still, and I think everybody heard the term condition monitoring. Maintain when needed, and prevent, let's say, unplanned stopping. But that is, of course, still 90% of the time that's not the case, unfortunately. And the third reason, or the third challenge we are helping our customers with, is to run more efficient, but also run more green in that sense. So you use less fuel or generate more electricity with a wind turbine. So we are a relatively small company. That the name already says it, Sensing 360. So we measure in 360 degrees, and our main focus is on marine and energy. Our customers are mainly in that region. We have some small projects in heavy lifting and drive lines, and for the longer term, we have some automotive customers. But we have a strong focus on critical assets, which large failure and downtime cost. And then the main value we bring, I always try to simplify it, but life of a mechanical component is in general defined by how much it carries and how long it runs. Well, we measure the load of bearings and of rotating equipment. So we measure the first, how much it's carrying, and luckily we are quite good at measuring time in the world. So together with that, we can actually determine very well how much life it has had and how much life it has left. How to do it, it's a bit about the technology. I think I'm not going to explain a lot about the photonic sensors in detail. If you want to know more, please contact us. But we use this optical cable with an interrogator on the other side, and we wrap it around, in this case, a sleeve. And this on the left, you see 6 points, and these are the sensors. They are located in this part. And every time, in this case, it's my hand, I pinch this iron ring, you see that we measure the total deformation. And by using algorithms to map the total deformation, we are able to translate the strain signals of the optical sensors towards speed, temperature, and load. And that's what we use to help our customers. And we have, in general, 3 parts where we help our customers. I already mentioned in the beginning, but it's improved reliability. I could have picked a lot of nicer pictures of the application, but I wanted to pick pictures where you can see our systems installed. So they're iPhone pictures, but on the left you see an electromotor, quite a big electromotor. And you see, if you look closely, the fiber coming out, and we are measuring the use of the electromotor in the field. The customer was knowing the electromotor is misused in the field, but they wanted to know how much, and they are now have changed overhaul time of a ship from 6 months to 10 months. So they are more reliable and they can run longer without doing the maintenance intervals. Secondly is availability. So monitoring when things are failing. In the back you see a planetary gearbox of a wind turbine. And the main reason why we are monitoring it with optical sensors is to see how much wind it has had. So if you put a wind turbine on top of on the North Sea, that's quite rough winds, but it's completely different from when you put it in the desert, for instance. So if it's in the field for 5 years, has it seen 5 years or 2 years of wind? Now, with our load and torque measurements, we are able to determine the used life and the remaining life. And the third application, it's probably very hard to guess, but this is a snow cleaner. You see a small fiber coming out. This is for a Norwegian company who makes snow cleaners for airports. Schiphol also has quite some of them. So they need to clean the track when there's snow, and they need to give a statement about how clean or what's the rolling friction after the cleaning. With our system, we measure the exact load on the wheels. We can determine the rolling friction, and with that feedback loop, the snow cleaner actually can clean more efficient. Sometimes they already know they have run enough, or it's already clean enough, instead of running 3 or 4 times because, let's say, protocol says so. So we have now a feedback loop of how well they cleaned it during the operation, which makes it more efficient. I think that's roughly it what I wanted to tell and wanted to show. So that is us. That is sensing.
Short and brief, and well, I would like to thank you for a wonderful presentation, but also ask our audience to put in their questions. My colleagues will pass on the questions to me and subsequently to the speakers. And also, if you miss your opportunity, for example, if you have pending questions to Peter Doyle, you can still put them in the chat. We will try to address them on our own behalf, or we forward them to Peter Doyle. So please do so. In general, there are no questions yet from the audience. I wanted to ask you, just from your journey in the company, how many years are you with the organization, with Sensing 360?
We started in the beginning of 2018. So we are now 4.5 years old.
4.5 years old. Well, I'm sure that the recording of this will be watched by a lot of PhD students and the very green and young spin-offs whom we usually have in the audience. So what would you say is the most important transition to start your own company, to have audacity, persistence, or perseverance to do so? Maybe you can give it's a bit of a deviation, but it's an important question also.
It's a crucial one. It is persistence. What I recall, and I'm not a young PhD who started this. I had about 15 years of working history before I started my own company. And the main reason I started my own company is that I spent about 50% of my time as project leader defending my projects, which were already approved, which is let's call it bureaucracy. And that freedom gives you so much energy, at least in my case, to start a company. But there's a lot of, let's say, moments you really feel, I don't know where we're going. I don't know where we will end up. And actually, I don't know even what we are doing. And that takes time to get the vision, or to get, let's say, a focus in there. And it's also quite a natural process. Of course, you can help and talking to a lot of people, and there's plenty of interesting ecosystems in that sense, with a lot of people who have been to this journey. But it is really finding your own way where you feel best with it, and it is worth doing it. I can be very honest, and it's also, it doesn't automatically involve 80 hours of working, because I have 2 little children and I also have to manage them. So it's also possible when you're in the later phase.
Oh, perfect. Well, it is a great presentation, very informative. I still do not have questions. Please do stay online, and I hope there's a lot of developments and interesting things to share for our future episodes. We're here to stay, and looking forward to hear more about your success. Yeah, thank you.
Thank you for your time.
And now we move to the next speaker. Okay, our next presenter is John Joosten. He's a marketing technologist at FuQon. I would like to welcome John, actually in person. It is a great pleasure to have you here. It's going to be a very mechanical process whereby I literally give you the stage and the floor. And
So, good afternoon, everybody. My name is John Joosten. I'm working for FuQon. We are located here on the HTC twice. We have a lab over there to build and develop models for our application. What we've done over the last couple of years, we have developed a quality system for terminals. What you see on a typical terminal is that there's, and we're talking about fuel terminals, we have inbound, so fuels are coming in. Within the terminal, there's blending and storage, of course, and there's outbound. And one of the biggest challenges of the terminals is that there's more and more sustainable fuels coming in, like ethanol, like SAF, so sustainable aviation fuel. And all those kind of different liquids need to be monitored. Typically, how monitoring is done in the past and still is via sampling. So a guy climbs up a tank, takes a liter of liquid, goes down, this liquid is sent to a laboratory, and eventually after hours or even days, the result of the quality audit is coming in. So that takes quite a while, and it's very cost ineffective. What we have developed is a process quality control platform that's able to monitor the quality of the liquids real time and continuously. I would like to show you a little film, but that's because of the technical malware, that's not possible. So I invite you to our website where you can find our FuQon profile film of only 2 minutes that will show you exactly what we're doing. So if we look to how manual sampling is done, what I explained before, what currently is going on. The problem is that people have to climb a tank. They have to inhale because they have to open the tank. That's of course not very good for your health. It's increased explosion risk. The other thing is that 1 liter of a 100,000 cubic meter tank can never be representative for the whole batch. And of course, it needs resources, it gives delays, and you have to send things to a lab, and it gives waste. So with the system, the platform that we have developed, there is a limit sample needed. We have a complete closed system, so there's no emissions. What also can be done is that there's a track and trace. So every second, the quality of the liquids is measured, and that's stored and kept on a hard disk. It's what we call REACH compliant. REACH is a European directory that says that you need to know what's on your site every second. And of course, it will decrease fraud, because there's still quite some fraud going on. For example, putting water into diesel, mixing stuff to just yes or just no, reach the correct quality. And what we see is that there's an increased use of sustainable fuels, and it's more and more needed to measure those fuels very carefully. How is this done? This is done via a near-infrared sensor. So we have a light source that sends its light through the liquid, and on the other side there's a near-infrared sensor. The sensors that measures spectrum. Every second there are 70 spectrums coming in. And on the right downside, you can see that there's a fingerprint of a diesel shipment, diesel batch coming in over a couple of hours. So we are measuring a lot of fuels, and we are getting a lot of data coming in via the near infrared spectra. Architecture of our system is that we have a Q engine that does the modeling, and we have the Q cells, just what I showed you, and through the Q cell, the liquid is flowing. We store the data from the measurements locally on the engine, the Q engine, as well as in a cloud. From the Q engine, which is basically a industrial PC, we can analyze, we can create a dashboard, we can create reports, and also send information to the DCS systems, so the distributed control systems of our clients. And in the cloud, we can do further analysis of all the data that's coming in. Also, we can measure and collect data from different customers. With that, we build our database, and with that, we can improve our models, and with that, improve results. We have developed this over the last couple of years, and now are in the phase that we are rolling this out into the marketplace. And to give you a little overview of the challenges we have had and we still have, is this slide, which tells about what's all need to come together to build a final product that's able to meet the needs of the customers. So we have to do with algorithms, of course, with modeling, with the optics of the whole system. What is important in our business is that it's ATEX approved, so the system as such needs to be capable of being placed in a dangerous environment, so a gas environment. We have a lot of systems, so there's measurement corrections between the system needs. We need AI, machine learning. We have chemometrics. We have a real-time operating system to put everything together. And so that's one of the reasons that we also have contacts now with Photon Delta, so we can hopefully find some other companies, some other people that have similar challenges, and that we could team with. Again, what I said is please visit our website, FuQon.com, for a better film, a better overview of what we are doing. Thanks so much.
I'm going to take my seat back. The steering wheel of today's episode. Well, thank you very much, John, for your presentation. I do not yet have questions from the audience, but again, we're a bit behind time. I encourage you by all means to go to YouTube and watch that video and reach out directly to FuQon. And as I already mentioned to the previous speakers, I very much hope there are so many developments, success stories, that you will be a guest in the upcoming episodes in a couple of months or years. So
Okay.
Yes, it's great to have you. So now we're going to move on. We have a last speaker in Who is Who section. So our last presenter in Who is Who section today is Hans Dijk, who is a business development manager at Surfix Diagnostics. I would like to welcome Hans, and we're very excited about your pitch, and our attention is all yours. I hope connection and everything is well. Let's check that.
Well, I'm sorry I'm here beside my voice, which is not that good today, but thanks
I can hear you perfectly well.
That's good. Thanks for the opportunity to talk a little bit about what Surfix Diagnostics is doing. And the only thing I can say after the two presentations before me is, and now for something completely different, because we are doing something completely different, but utilizing photonics. And I will share my screen.
We're all for diversity, so this is excellent.
The problem is...
There are often little technical hiccups, so
Yeah.
bear with us.
Well, here he is.
Yes. Perfect.
Well,
Perfect.
again, I'm the guy in the picture over there. If you go to number 2, I have some text and I have some pictures and a few drawings to show you. Basically, what we have seen in the last 10 years is that a lot of new biosensor technologies have emerged. Basically, the requirement is that a lot of things aren't sensitive enough and have to be quantitative, and in some cases even multiplexable, which means that you can detect more than one biomarker at the same time. And thus, there was a need for new technologies, and we are working as a company on one of those new biosensor technologies, and it's called a photonic biosensor. So we're using light as a source of transmission of signal. That means that you can work very sensitive. It's quite fast, and one of the advantages over other technologies is that it is label free, so you don't get a color or you don't get any other readouts that might be interrupting with the signal which is coming from the biomarker. So that's a feature that people find very beneficial. Basically, we are looking at 3 parts we are working on at the same moment now. First of all, there's the photonic biosensor. So that's a very small chip that's also used in, let's say, things like the 5G networks, where actually the signal is measured. That is combined with a microfluidic cartridge in which it is embedded. Read before the sample can go to the photonic sensing part. Something has to happen, so read it as a sort of a lab on a chip. One thing you have to bear in mind, and that's where we're coming from as a company in the past, is that all those materials are made of plastics or other materials which are very difficult to bind biomarkers, enzymes, DNA to. We could combine it with nano-coating technology we already had in-house, and together with the reader we require in the end, you will have a lovely diagnostics platform. So if you want to go to the next slide, please. Yeah, thank you. So here there are a couple of small drawings. What you see here on the left is a very small chip in the middle embedded in a microfluidic cartridge. In the middle you see a reader in which the biosensor is shoved into, and it's a plug-and-play system. So basically, if you alter the markers on the chip, you can detect other things. Next slide, please. So here, 5 pictures to get a bit of the real life. What you see on the left is our lab system, which we are using at the moment in the lab. Basically, what you see here is a lot of tubing, wires, and so on. It's going to be much simpler, as I've mentioned before. The picture on the right depicts that a little bit. That is a functional model, and it is without a housing. But it's a functional model of the reader with a functional model of the cartridge and the chip inside with a big white dot on it. In the middle between those 2 pictures, you see a real picture of one of the sensing elements. So it's a big coil through which the light is going. And on the left bottom and middle bottom, you see the chip. On the left, you see the size of it. It's only 10 by 15 millimeters. Next generation we're working with at the moment is 3 by 3.5 millimeters, on which we will have 12 sensing parts. And in the middle bottom, you see it embedded in the cartridge itself. So if you want to go to the next one. Thanks very much. roadmap, where are we and where are we going to? At the moment, we are looking for all kinds of partnering projects. Basically, the only thing we don't have is, let's say, the requirement for which test is required in the market. By the way, we are working on early cancer detection, which is a DNA project. We are working on pathogens in aquaculture. So read the culturing of salmon and all kinds of other culture fish. That's also a DNA project, which can be found under PhotoSense. It's a European thing. And the third main thing we have been working on, which is more or less closed at the moment, is a protein-based project in COVID-19, for which we have a number of white papers and an article out. And here in the roadmap, you see what we have depicted to do in the next couple of years. So basically, we have to work on the multiplex detection. That's a very important part of what we're doing. And one other important thing, and that's from the business perspective, is that the cartridge, together with the chip, has to go to a certain price level to make it interesting to the market. And then, of course, we have we have seen that the possibility of growth to a number of people and a certain budget must be able to do in the next couple of years. So thank you for that. And then we go to the next one. And that's all I wanted to say. If you want to know more, check us out on the web, and otherwise drop me a line. Always ready to answer questions. Thank you, Nilüfer.
Hans, it was an excellent presentation. And just looking at the last slide about the roadmap, I think we can elaborate on each and every of those things and prospects which you're working on. Unfortunately, we're running out of time. I think there might be questions that are popping up in the chat. Please feel free to answer them in due course. Till the end of this session, there's still plenty of time. Otherwise, I would strongly advise our audience and those who will be watching recording to check out the social media websites and follow Surfix Diagnostics for all the exciting developments. Hans, I've learned a lot and I'm genuinely curious about your roadmap and the next steps. So thank you very much for joining and enlightening us on what is happening within Surfix.
Thanks for the opportunity, Nilüfer. Thank you.
Great. So now we will move on. Today's episode of that I'm hosting of Delta Dialogues will conclude with the section that is called In the Spotlight. And today we have a special guest, Tim Tiek, who is a board member both at Holland Semiconductors as well as High-Tech NL. Tim will share with us, as far as I understand, with his vision on the exciting worlds of both electronics and photonics. And I'm genuinely looking forward to hear your perspective. So, Tim, the stage is yours. I hope connection is well. Please begin.
Thank you. Can you hear me loud and clear?
I can hear you very well.
Okay, great. So, thank you for the introduction. I will also share my screen. I really want to zoom out quite a lot. We have seen some quite interesting companies, startups, and there are many companies in the landscape who may become the leaders for the future in the integrated photonics. But what I would like to do is really zoom out. That's what I've been asked to do on how do I see from a perspective of the semiconductor and the total high-tech landscape, where we are with integrated photonics and what's happening. So what I will do, let me share this one. So, can you see my screen? Is my screen visible?
Suzanne, can you confirm that, please?
Yes, the screen is visible. Yes.
Okay, great. So really zooming out, and this is, as you can see, focused a bit on the Dutch landscape, but obviously it's much broader than that. This is a European perspective. Quick word on myself. I have a background in many different markets, but the main focus has been semiconductor, especially over the last 5 years, where I was the CEO of a company called FuQon and Surfix Circuits and some other daughter companies around it, really working on chip design. Before that, I've been working also in telecom, in automotive, in energy storage. I have been involved in Photon Delta for about 2 years now. Not so much because I've been doing any of the integrated photonics work myself, but because we have been working with the companies within the ecosystem, also about things like interface chips, interfacing with the photonics chips. So that's why I would look from that perspective. And this presentation that I will be giving is just my practical, I would say, bird's eye view. Consider it as my personal opinion. So just want to mention some things which may resonate or lead to some interesting discussions later on. So first of all, if I look back 2 or 3 years, what do I see happening in the integrated photonics scene? I think it's really very promising that we have, of course, the history goes back way, way longer than that. But over the last years, we see it being applied. And we see companies spinning out, and the larger companies like in effect Photonics or like Photon First, really getting some traction. I think could become future worldwide leaders in their fields globally. And if you even look further in the total landscape, we have many SME companies, not so many really large companies driving like an ASML or the NXPs. And I think we can definitely find amongst the crew today one of those for the future. I've also seen a little bit longer ago, especially when we are talking to politicians, The Hague, there was something like integrated photonics will replace all electronics. We don't need to do anything about electronics anymore. I think that's, I don't hear that any longer, so I'm glad about that. I think it's really hand in hand, and I'll show a bit more about that. So the collaboration is improving. I see this from also from High Tech NL, where we have about 230 high-tech companies, and the discussions with Photon Delta and its partners. I think it's really heading in the right direction, but also the politicians. We used to also have a little bit longer ago, somewhat of, I would say maybe even somewhat of a tension between Eindhoven and Twente areas. I don't see that so much any longer. I think it's improving. However, my personal view, I think a lot of money and time is still being spent by perfectionizing technology, which is natural for engineers to do. But I see sometimes technology is really exciting and it's really good enough to go to market or close to that. And then years and millions are spent to perfectionize it, where not enough money and time is spent on the business development and the process engineering. I'll get back to that later. I think that is really something that is needed if you want to go to a higher TRL level and maturity. If we want to scale it up, in the Netherlands, in Europe, I think there's much more focus needed on developing lead customers and across ecosystem cooperation. I said it is starting, it is heading in the right direction, but we're not there yet. And specifically for the Dutch DNA, if you will, I think we are a country with excellent innovation. I'll get back to some of that as well. We have a lot of smart people in the industry. The cooperation amongst engineers is good, but we still have some small thinking, selling cheap, what we've seen in the past as well, over the last decades. Companies with really promising technology, and in the end, a large American company walks by and buys it. Not necessarily a problem for the people running the company or for the employment, but I would really like to see it materialize towards one of the next larger companies. So, and then just my personal opinion, I think the most potential that I see is in data and sensors applications specifically. I would like to share also one analogy that the way I see basically the involvement of electronics, the classicals. And simple example is a sensor. So if you have a sensor, you measure something, and it's always analog. It's always something in the world, because that is all analog, right? In the past, we had in the electronics, everything that we processed was also an analog until in the 80s or a bit earlier, the digital designs came. Now what we see now is we want to transfer things to digital quickly, do all the processing there. But in the end, we still need a user interface, or we need to do something with it that is in the end for humans. We don't build it for anything else than for ourselves in the end. And people, they are also still analog. So maybe it's a bit of a no-brainer, but the reason I explain this is because if I now look at photons versus electrons, I think it's a bit the same. So there is an analogy that that we can make here. We have inputs and outputs. We want to either measure something, or we have data to be transmitted, or whatever it is. And within this scene, we have the photonic ICs, and they are great, and you can do a lot with them, and it has huge benefits over discrete. However, you still need light sources, photodiodes, and of course other electronics. You need some digital to process it. So in the end, it is, the way I see it is a little bit, in the past we had only analog electronics. We added digital. There's a lot you can do with that, but one cannot go without the other. It's always both. Yep. I think with integrated photonics coming up, you have the same thing. You have the traditional electronics. It looks like a mature market, but it really isn't. Even after more than 60 years, it's still evolving. And if you add integrated photonics, I think it is really the strength that you have both, and that you have this tight interface and the integration. And I'll come to an example of that. So I think one cannot go without the other. The world is still analog, people are still analog. So, and I'll get back to that in a moment. Just first, some of the challenges that I think are all familiar to you. If we look at tying integrated photonics systems to traditional electronics, and you have all these challenges that I think many of you are facing. We have the packaging, we have the way to align fibers. Thermal management is an issue. Then you run into the materials, the mechanical design. It all is very compact. It is dissipating heat. You have all these things. You have to pick design, also not that straightforward, because you need the libraries, you need the tools, production. If you add all this stuff up, they are basically similar challenges to what you see in the semiconductor industry, only material levels are higher there. I think what is structurally underestimated, what I see at some of the companies, is the process engineering and the reliable production ramp up. So we are really focused a lot on the technology, perfectionizing it. In the end, when I was at Sensata, we were making hundreds of millions of sensors per year. If you had the initial design, it was perfectionized, it was working 100%, you would be only at 20% of the total of the project, because the process engineering and getting high volume out at the right reliability, doing all the testing, that was actually the biggest part of the work. And many people coming from the academic environments, they don't always see that. I really want to emphasize, spend time there. Don't spend all the time and effort on the core technology. Really make sure that you can actually make it and at a good quality and scale it up. So maybe coming to Thomas, a little bit to the end. Semiconductor IC it's about 65 years old almost. So you see Jack Kilby on the right. And even today, with all these huge semiconductor companies and the TSMCs of the world, etc., you see that no single company can master all the steps. So there is no company making a complete device, all the chips in it, and doing all the steps of the process. And the design, the package, production, testing. So even if such a mature market cannot do it, it integrated photonics, you also have to partner up. And I think it's happening. I think it's happening much better than a few years ago. You cannot do it by yourself. You have to work with each other. You have to work with lead customers, application experts, make sure you really know the application you're aiming, but also the high TRL partners for the electronics and all the other elements. So reach out. The way to do it, I would say the second bullet here, if you look at Photon Delta, is of course trying to gather everybody together and do it together, and did a great job putting it on the map in a relatively short time. And I think Photon Delta secured a lot of funds. That is quite a unique position. There are many other industries that did not have the privilege of such a kickstart. And I think it is, we have the ingredients there to become this world innovation leader. The knowledge is there. What is also important, maybe not everybody realizes, there are also high TRL, high-tech companies in the Nijmegen, Eindhoven, Twente areas that are willing to help. They have a lot of knowledge in-house. How do you scale things up? How do you basically connect it all together? How do you open the doors at multinationals? All these things. There is a willingness. You just have to connect. And I think we have, I put the 4 names here. I think there are more. We also heard Peter Francis talking about willing to connect. But the ones I want to mention here, obviously Photon Delta, Holland High Tech is there, High Tech NL, and Holland Semiconductors. Holland Semiconductors is about 70 semiconductor companies in the Netherlands. High Tech NL is about 230 high-tech companies, including robotics companies, etc. So I think if we do all this right and we do not sell this technology cheap, we really make all the elements of the puzzle work. We can maybe on the right add integrate photonics to the long list of historical innovations. Yeah, I think it can be done, and I hope it can be done, and that there will be a good landscape of larger and smaller companies keeping the lead in the technology. Yeah. That's my personal view on things. So, and I think it's also time, right?
Yes, Tim. First of all, I'd like to thank you for your perspective. It was a very rich and informative presentation. And just me on my own, I could come up with 12 or 15 more questions. We're a bit out of time, and I don't yet see questions from the audience. I think you mentioned really big, high-level things that are important and they matter. So I'm going to ask you one question.
Yes.
I have a great appreciation to the fact that you emphasize interconnectedness, almost going hand in hand between microelectronics and the integrated photonics. I think this has to be bared in mind and appreciated. But one important thing is the next hurdle is to professionalize the technology, and there is not enough money or emphasis, as you believe, is sitting in the business development and process engineering. You also mentioned from the beginning that you see a lot of political support, and these topics are prominent among the politicians. Do you think it's enough, and just how important is still a very powerful, very centralized, and very tangible policy and political support in the Netherlands, but also in EU, if we want to be a world leader, let's say, in advanced semiconductors that will have both the capabilities of electronics and photonics?
Yeah, so it has to come from within the companies in the end, the ambition. So what I see is right now the landscape is really favorable. There is funds available because of the geopolitical trends. Everybody is aware that it's really important to cherish technology and try to keep it local, but and invest in it. personally, I don't think it's really a limitation right now of the political support and even the funding. I think and it's not only for integrated photonics, it's also for several small, medium enterprise, high-tech companies in the Netherlands. You also have to have the ambition and you have to make it known. So if you are a company, let's say you're 20 people, you have exciting technology, you can conquer the world with it, and you say, hey, I want to be like, and let's mention a company here, Demcon. Demcon grew to over 1,000 people from a small, medium enterprise because they have the ambition and they have the growth. So I think that is right now the key element. The political landscape may change, so it may not be, maybe in 1 or 2 years' time, there will be another hot topic. I think now is the time to make it known, hey, this is the roadmap I have. We just saw the roadmap. Make it for yourself and ask help to complete it. And don't do everything by yourself.
Perfect. Well, I think the answer is very clear to me. So top-down attention and commitment is there. It is essentially bottom-up mobilization, bottom-up clarity on what exactly is needed and where you're going and why it's important that needs to be improved, so to speak.
Yeah, and don't fight each other. I think right now in the stage where the companies are, don't see each other as competitors, try to fight each other. Don't. I see. It's only a minority. I see some companies trying to fight for some funding that's available or so. That is really not the right thing to do, because if we do it like that, you lose the momentum and somebody else in another part in the world will take over. Look at the semiconductor ecosystem and all the collaborations there. And I think, if you build a similar interconnected ecosystem, it's just key for success.
Okay, as I mentioned, Tim, I could ask you 10,000 more questions. I really appreciate your time and your perspective, also considering your very extensive and broad background. I very much hope this is not our last encounter. And with this, I have to move to concluding our session. Thank you very much.
Thank you too. All the best of luck to everybody.
Yes, thank you, Tim. Thank you. Well, I think we have come to the end of today's episode of Delta Dialogues. This was episode 4. And if you're willing and interested in contributing to the upcoming episodes content-wise, or you have some exciting topics and questions that are of particular interest for you, please follow this QR code. There is a form on our website that you can fill in, and it will be very much appreciated. Also, we very much appreciate your feedback and ideas on how we can better improve these series and how we can better service this community. Please follow the hashtags, the QR codes, not the hashtags. Please keep an eye on our posts on the social media and LinkedIn for the exciting program that we have for you on October 5. And on October 5, as I already mentioned, my colleague Jorn will be back to host you with many more speakers and a lot more in the room for you. Thank you very much, and I'd like to thank all the participants online. Do share the recordings that will appear and will be posted on our website and social media, and I look forward for the future encounters. Thank you very much. Bye.